Hi guys, good morning.
Good morning, sir.
Morning, sir.
So yeah, let's begin integration today. Last class we did mathematical reasoning, and the session before that we completed statistics. These are all scoring chapters, guys. So if you missed the class, please watch the video again. All right? Got this? Okay. Let's begin. You guys tell me integration formulas. X power n dx. You have already done this. That's why I'm asking.
X power n plus 1 by n plus 1 plus c.
Plus c. Good, good, good. Next. 1 by x dx.
Log mod x plus c.
Mod x plus c. Very nice. Very nice. E power x dx.
E power x plus c.
Okay. A power x dx.
A power x by log a plus c.
Log a plus c. Nice, nice, nice. Then sin x dx.
Minus cos x plus c.
Minus cos x plus c. Not bad, not bad. Obviously, what is the next one? Cos x dx. What is cos x dx?
Sin x plus c.
Okay. Sec square x dx.
Tan x plus c.
Tan x plus c. Cosec square x dx. Cosec square x dx.
Minus cot x plus c.
Good, 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 good. Sec x tan x.
Sec x plus c.
Sorry.
Sec x plus c.
Correct. And this one, cosec x cot x. Cosec x cot x.
Minus cosec x.
Okay. Then integral cot x dx. It will be
Minus cosec square x.
no.
Log mod sin x.
You differentiated this in your mind. Log mod sin x. Plus c. Okay. Integral tan x dx.
Log mod sec x plus c.
Okay. Sec x dx. Log mod sec x plus tan x plus c. Okay. Then, of course, cosec x dx.
Log
Minus
mod
log.
cosec x minus cot x.
Okay. I write it as, it's the same thing, okay? Like, you said log mod cosec x minus cot x, right? They're both essentially the same because if I multiply and divide by cosec x plus cot x, it will become cosec square x minus cot square x in the numerator and cosec x plus cot x in the denominator. And you know this value is 1 here in the numerator. Okay, so you write this as minus log cosec x plus cot x. Right? Then, what else do we have? Yep, the long formulas are here on the way. A square minus x square. What does this come out to? The inverse x by a, right? You done this formula before?
Yes, sir.
Yes, sir.
Okay, then minus dx by root a square minus x square is equal to
Cos inverse x.
cos inverse. Yeah, same thing, but cos inverse. Next, dx by a square plus x square. What is this?
1 by 8 tan inverse x by plus
1 by a tan inverse x by a. Good, 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 very good. Let's see here. 1 by a
Cot inverse x by a plus c.
plus c. Then we have dx by what does this come out to?
secant inverse x by
Sec inverse x by a. Don't forget a 1 by a outside.
no 1 by
Yeah.
yes
What about this?
1 by a cosec inverse x by
Sec inverse x by a plus c. All right. Now, let's do a couple of questions now quickly. Sin power 6x plus cos power 6x by sin square x cos square x dx. Okay, what does this come out to? One guys quickly find. What is this, guys? Numerator you write as sin square x plus cos square x, the whole cube, minus 3 sin square x cos square x into sin square x plus cos
Then I
square x.
got tan x minus cot x minus 3x plus c.
We'll find out, we'll find out. Then this becomes 1 minus 3 sin square x cos square x divided by sin square x cos square x dx. This can be written as what? 1 by sin square x cos square x minus 3 dx. Now this one I write as sin square x plus cos square x. Okay. And then this becomes 1 by cos square x, which is sec square x, plus 1 by sin square x, which is cosec square x, minus 3 dx. So this simply becomes tan x, yes, minus cot x, minus 3x plus c. Okay. Any doubts here, guys?
No, sir.
So I'll give you another question. Cube by x plus 2 dx. Come on. What do you get here?
First, you have to divide the numerator. You can write it in terms of
You're on the right track. We use the denominator. The best if the numerator is written in terms of the denominator. This is your clue. X cube plus 8. What will you write that as? Here x plus 2 cancels out. You get x2 by 3 plus 4x minus x square minus 8 log mod x plus 2 plus c. Got this?
Yes, sir.
Rest of you, any doubts?
No, sir.
Okay, then do this question. Square x square plus 5 dx. Very simple. Come on, quickly. What do you do here? Quickly solve and tell me the answer. I just want to hear the answer.
So 1 by root 5 tan inverse x by root 5 plus c. Oh, wait,
Wrong.
sorry, it's x square.
But x by tan inverse x by root 5 is involved. Which means you're not completely wrong. It's just wrong. Okay. How do you start solving this?
Sir, you have to put it as plus 5 minus 5 in the numerator.
Lovely.
Sir,
Okay,
this
correct.
is
Correct.
x plus root 5 tan inverse x by root 5.
Becomes 1 minus 5 and 5 by plus 30x. This becomes x minus 5. And then this, when we integrate, we get 1 by root 5 tan inverse x by root 5. 5 and root 5 will cancel out, and root 5 will remain in the numerator. And this will be our answer. Okay. Any doubts here, guys?
No, sir.
Okay. Now, yep. Move on to the next question. Okay, come on, quickly do this. This plus 1 minus 2. This minus 1. And then this becomes x square cubed plus 1 divided by x square plus 1. That is x square plus 1, x power 4 plus 1 plus square divided by x square plus 1. Here minus 2 divided by x square plus 1. Here it becomes 5 by 5 plus x cubed by 3 minus 2 tan inverse x plus c. Okay. So we know basic integration now, right?
Yes, sir.
Okay. So, when I say y equal to, sorry, when I say y equal to x, and then I say x dx comes out to x square by 2 plus c. What are we talking about here? So x is a function, okay? Y equal to x, this is the function here. Now, this function into dx, what does that mean? So you take one small part dx here. Okay, it should be very tiny. It should be like a line. When you multiply that by this value, what are we finding? The area of this rectangle, right? So when I integrate, basically, I am adding such areas. All right. Getting this, guys? So dx is so small, it will look like a line. So basically, I'm adding different small lines up. Are you following? Like it's very thin, dx. Okay. Right. So like this, you keep adding different lines up. Basically, you'll end up with an area. If you put limits a and b, suppose this is a and this is b, you'll find the area between a and b. That's what is happening. Between the x-axis, the graph, and a and b. Understood? That is what you're finding here. Now, without this, you'll get a plus c. Okay. So it means this function here, at any point from a to b, this function can help represent the area, right?
Yes, sir.
Yes, sir.
Okay, so basically x square by 2. Let's try to construct x square by 2. We know conics, so y equal to x square by 2 is an upward facing parabola. Okay, so whenever I integrate, it's equivalent to the value of x square by 2. Okay, plus c. What is happening here when I say plus c? It can be this curve, it can be this curve, it can be this curve. Okay, so the idea is if you put a value of a and a value of b for each of these and subtract, you will notice that we are talking about the same difference, right? When I put a and b, what happens here? It becomes b square by 2 minus a square by 2, right? You put the value in. Like basically c and c will cancel out. So basically it's any of these curves that are possible. Okay, any curve of this type, any parallel curve can represent this. All right, for that particular value of a and b. I hope this was understood. I'm hoping you knew this already, but yeah. Did you get this?
Yes, sir.
No doubts here? All right. Then how would you take care of this, guys? How do you take care of this? We substitute ax plus b equal to t and then differentiate. What happens? A dx equal to dt and then substitute that here. So this becomes t power n and dx is dt by a. So integrating this, I get t power n plus 1. T is ax plus b power n plus 1 divided by n plus 1 divided by, okay, don't forget your plus c. So this is what you're substituting. So what did you basically do here? You integrated it as if it was one element, okay, and then divided by the differentiated version of that one element, okay. Understood? Which is A. Got this, guys?
Yes, sir.
You guys know this already here. You just look at it carefully. If you're not understanding, please ask. Now, quickly find the answer.
Sir, is it 1 by 24 into 4x plus 7 into 3 power 2, 3 by 2 minus 8 root of 4x plus 7.
How did you proceed? I think that's the wrong answer, but as in I'm not getting the same answer here. But let's solve and find out. So, how did you proceed?
So I took 4x plus 7 as t.
Okay. Root t, it becomes 2t minus 1, right? And then dt by 4 dx. Okay, this is what we need to find. I split this into two parts. 2 by 4 e by root t is root t. This is coming here. And then minus 1 by 4 into root t dt. These are two parts here. One is t power 3 by 2 by 3 by 2 by 2 minus t power, like minus 1 by 2 becomes t power 1 by 2 divided by 1 by 2. So 2 and 4 will cancel out to give 2 plus c. So this simply becomes 4x plus 7 raised to 3 by 2 by 3 minus 4x plus 7 raised to 1 by 2 by 2 plus c. Now this, got a mistake with that?
Yes, sir.
Okay, next question. Sine of log x by x dx. Come on, do this.
So minus cos log x plus c.
You take log x as t, what happens? Dx by x becomes dt. You see dx by x here, which is dt. It becomes sin t. Sin t when you integrate, you get minus cos t. As simple as that. And cos t is log x plus c. You said the same answer, right?
Yes, sir.
No. Yes. You guys quickly do this. Come on. What do you get this as? Take 1 minus x is t. Okay. What is this problem? When you see a product, what do you do?
Multiply and divide
Multiply and divide by?
2.
Why?
So that we can find 2 cos x into cos 2x as cos of a plus b using that formula.
That's what you split it into a sum. Okay, what you said is correct. You split it into a sum here. So we know that cos a cos b can be written as like basically 2 cos a cos b is cos a plus b plus cos a minus b. So this whole thing is divided by 2 here. So here this becomes cos x, I'll take common, and cos 2x cos 5x becomes cos 7x plus cos 3x divided by 2. And then I get 1 by 2 cos x cos 7x dx plus 1 by 2 cos x cos 3x dx. Okay, apply the same thing here. This becomes 1 by 4 cos 8x plus cos 6x plus 1 by 4 cos 4x plus cos 2x. Integrate cos x, what do you get? Integrate cos x, what happens?
Sin 8x by 8.
Exactly, sin 8x by 8 plus sin 6x by 6.
Sir, is it not cos 3x and cos x in the third step?
This one? What about this
So
one?
1 by 4 into cos 8x plus cos 3x.
Cos, come again. I didn't get it out.
Third step.
Did I just underline the correct step, or is it the upper or lower step?
The lowest step.
Lower step. Okay, this one.
Oh, yes.
What about this? What about this?
Is it not cos 2x plus cos x?
Cos 2x plus cos 4x.
Oh, okay, sorry, got confused.
Cos a plus b plus cos a minus b.
No, sir, it's correct.
Okay. So let me just check to find the answer. Is it the same thing I'm getting here? Yeah, it's the same thing only. Yeah. Then, okay, let's move on to our next set of formulas. Okay, that's it. Yes. We already deal with this. This we know is 1 by a tan inverse x by a. Okay, now dx by x square minus a square. What does that become? 1 by 2a log mod x minus a by x plus a plus c. Please remember this, guys. You can derive this, but I would suggest you remember this. Okay, how do you derive this? So 1 by x square minus a square, you will write that as 1 by x plus a, 1 by x minus a. You will make them interact to become 1 by x square minus a square. If I add them up, what happens? 2x happens. If I subtract them, what will happen? So I'll make this 1 by x minus a, 1 by x plus a. So when I subtract them, numerator will have 2a. So to make up for that, I'll divide by 2a. So this is where the 1 by 2a comes. And then when I integrate these parts separately, I get log x plus a, log x minus a minus log x plus a. Log a minus log b is log a by b. So that is how I get this. Okay, what is this becoming? Same idea here, okay? Same idea here, just that it will be a minus. Okay, and that will make it a plus x by a minus x. Fourth one. Okay, what about this?
Sin inverse x by a.
Okay, what about this? It becomes log of and here sorry x square minus a square. So here you simply substitute x equal to tan theta. And here you can substitute x equal to theta. So theta minus 1. theta or cosec theta, your wish. Okay, this is tan theta or cot theta, as in for the derivation purposes. Okay, now then comes root of a square minus x square dx. What is this? Square plus half a square sin inverse x by a plus c. Please remember this formula. Okay, please remember the next two formulas as well. Root of a square plus x square dx is 1 by 2x. Root of a square plus x square plus 1 by 2 a square. Okay, so do you know how to remember the last three formulas? So how to memorize it? I'll tell you how to do that. It all has the same pattern. Okay, that's why I wrote one under the other. Okay, they all have the same pattern. 1 by 2x into this thing itself minus or plus 1 by 2 a square. Okay, so notice everything has a square by 2 outside it. So first thing will have 1 by 2x outside it. Second will have a square by 2 outside it. Only in this case will it be minus here. And then what do we have here? Log of. So this is the integral when this was in the denominator. If I ask for 1 by root of a square minus x square, I'll get sin inverse x by. This was the integral of 1 by root of a square plus x square. Similarly, this is root for 1 by root of x square minus a square. Okay, please keep this in the back of your head. Do you understand how to remember this? Or do you already know this? Guys, please respond.
Understood.
Okay. Whenever you see a square plus x square, replace it with a tan theta or a cot theta. Whenever you see a square minus x square, replace with. So these are some common substitutions I'm teaching you. Okay, tan theta or a cos theta. Whenever you see x square minus a square, replace it with a sec theta or a cosec theta. Then we have root of a minus x by a plus x or root of a plus x by a minus x. You replace x with a cos 2 theta. Okay. Because you know 1 plus cos 2 theta. What is that? 1 minus cos 2 theta. Okay, so you'll be using that. So 2 and 2 will cancel, cos square, sin square will be there. When you remove the root, it will become mod of tan or mod of cot. It's much easier to take care of. Okay. So shall we continue? Are you ready with this? People?
Yes, sir.
All right. Okay, so first type of questions. X by x square plus bx plus c. X by root of ax square plus bx plus c. Root of ax square plus bx plus c. How do you integrate these? Okay, the method is to complete the square. Okay, you guys know how to solve all these already? If you get anything like this, How would you solve it? Okay, we'll do a question. 1 by x square minus x plus 1 dx. Find this, please, quickly. I've given the clue also. Complete the square.
So this is 2 by root 3 tan inverse 2x minus 1 by root 3 plus c.
Correct. Correct. So this is why you complete the square. Once you complete the square, what will happen? You will get it in one of these forms. Okay. Once you complete the square, you will have to get it in one of these forms. That's what will happen. Okay. This is what you replace x minus 1 by 2 with t. So then it look like this dt by t square plus 3 by 2 square. So 3 by 2 is a. So then it's the form you're familiar with, right? This would be 1 by a, which is 2 by root 3. Tan inverse t by a. So t is x minus half, and a is 3 by 2. 2 and 2 cancel out. This becomes 2 then. Yeah. So you get 2x minus 1 divided by root 3 plus c. Understood?
Yes, sir.
Okay. No need to even tell me the answer. Please solve this. Tell me once you get the answer. What happens here? So first you convert it into that form, you'll take root 2 outside. Okay. Understood? So then it becomes x square minus 3x by 2 plus 1 by 2 dx. Complete the square. Can you tell me the steps what you should do? First is complete the square. And then what do you get here? Root 2. Minus 3 by 4 the whole square. You have 1 by 2 outside. So plus 9 by 16 came here. Which means 1 by 2 minus 9 by 16. What does that become? This 8 by 16
Minus 1 by 16.
minus 1 by 4. Yeah, exactly. Minus 1 by 16. So it becomes minus 1 by 4 the whole square. So you're looking at root of x square minus a square. Okay. So that is the last one here. So apply this formula. That's why I want you to remember this. This is very useful. All these. Derive it once and then remember it. That's the point. All right. Let's just continue. Understood? So this will take some time. So to cover more concepts, let's just simply continue. So you got the flow. Anybody has any doubt how to complete the question? Any doubts?
No, sir.
Okay. Then okay, these are sneaky questions. Come on. take whatever is inside the root as t square. Guys, this is a common substitution you will see at many places. Whenever you have a doubt, okay, what to do, try this. If there's a root anywhere, inside the root, that thing should be positive, right? Inside the root, whatever you put should be positive. You take that as t square and try. You take it as t, it will be little more steps, but then you get the same answer. But take as t square and try, see what you get. You can see e power 2x goes in the denominator here. E power 2x can be written as 1 minus t square. Okay, from here. So that is why this is useful. So you can just directly substitute here 1 by root of t square, and dx becomes minus t dt divided by 1 minus t square. T and root t square cancel out because, okay, self-explanatory. And from here you can take care of the rest, right? You have dt by t square minus 1. Okay, from you here you can handle it, right?
Yes, sir.
1 by, what is the formula for this one? 1 by 2a log
Log x minus
X
a.
minus
by x plus a. Okay, lovely. And move on to the next type. Suppose you have px plus q dx divided by root of, root of x square plus bx plus c. Or you have some px plus q dx by root of x square plus bx plus c. Then px plus q into root of x square plus bx plus c. Okay. So you split it into multiple parts. That's the idea. Okay. The numerator, this px plus q, is split into two parts here. Px is one part and q is in the second part. You will integrate both separately. All right. So, second question. Okay, how do you integrate this? Don't take a minus x by a plus x as t square, okay? Can get complicated. Take care of its conjugate. Okay, so you get root of a minus x the whole square dx divided by a square minus x square. So this becomes integral a by root a square minus x square dx minus x by root a square minus x square dx. Got this? In the first one, you apply the formula. Second one, put x square equal to t. Or a square minus x square equal to t. Whatever is inside the root, take that as t or t square, your wish. Okay, got this? The first part becomes a sine inverse x by a. The second part here, what do you do here? You take a square minus x square as t square, and you get minus 2x dx equal to 2t dt. So then x dx becomes minus t dt, and root of a square minus b square becomes root of t square, which is t. T and t cancel out. You get plus t here. And what is t? Root of a square minus x square plus c. Any doubts here, guys?
No, sir.
Hmm?
Sir,
Yes, yes, yes.
so can we apply x equal to a cos 2 theta, sir, here?
Yes, 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 yes. X equal to a cos 2 theta is good. Because you will get root of tan square theta, right? That will become tan theta x equal to a cos 2 theta. So dx becomes minus a sin 2 theta d theta. This becomes minus a sin 2 theta d theta, and this is what we are integrating. So this is minus sin theta into a into 2 sin theta cos theta. Okay, tan theta sin theta by cos theta. I'm so sorry about that. Okay, d theta. So you get it as minus 2a into sin square theta. Sin square theta you can integrate, right?
Yes, sir.
Write it in terms of, you can write it in terms of cos 2 theta and then integrate it. No issue. Okay. Then comes the third type. They're all like similar types, okay? X square dx plus c dx, where k of x is a polynomial of degree greater than 2. Till now, the numerator was having polynomial degree less than 2, right? Less than or equal to 2 was. Even if it's equal to 2, what do? You know what to do. You simply divide it and then write the remainder divided by denominator in the next part. Okay. So this is the same thing you do here. Okay. You divide. You write this as sum qx plus remainder divided by x square plus bx plus c. This you can integrate separately, not an issue. This you now know how to integrate. Okay. This is your technique. Got this, guys? So you get some complicated, okay, question like this. What do you do here?
Divide it and write it in terms of quotient and remainder.
Correct, correct, correct. You bring it into this form and then try to get the answer. Okay. Right. So let's just move on to the next question. Okay. If something like this, what do you do? So the thing is, if I take this as t, what is dt? That is 1 minus 2x. So it would have been convenient had this been taken as t and then I see 1 minus 2x outside, right? Okay. So you write this part which is outside x in terms of this. Okay. So it's a into some 1 minus 2x plus some constant b. Understanding? I don't know the value of a and b. I'll have to figure that out. But this is how I'll split this part which is outside. Okay. Whatever is outside, I'll write in terms of the differentiated value of whatever is inside the root. 1 minus 2x plus b. So here it becomes a plus b minus 2ax equal to x. Here directly you can equate the x coefficients. We can say a is equal to minus 1 by 2. And then the constant term here is 0, and that you'll equate with a plus b. A plus b is equal to 0. B is equal to minus a, which is 1 by 2. Got that? Okay, you just write it in terms of the differentiated value of whatever is inside the root, whatever is outside. Write in terms of the differentiated value of whatever is inside the root.
Yes.
Okay, then. You understood, right? How it becomes easier to this thing differentiate. So this becomes a, which is minus 1 by 2, into 1 minus 2x root 1 plus x minus x squared dx plus b, which is 1 by 2 into root 1 plus x minus x squared dx. Okay, this you know how to integrate. This you take this entire part as t, then this and this together becomes dt, and minus half is what remains. This you can easily integrate. Okay. Right. Now the namesake type, I think you already know how to solve this. Already explained. X square plus bx plus c divided by px square plus qx plus r dx. Then ax square plus bx plus c divided by x square plus qx plus r dx. What do you do here? Ax square plus bx plus c. You will write in terms of some lambda into this part. Okay, px square plus qx plus r plus mu into its differentiated part, which will be 2px plus q. Okay, you write it in this form. You find values for lambda and mu by equating the coefficients. Or put any value for x. This should be satisfied for all values of x. Okay, it's lambda and mu. So you put any value for x, you'll get some equation just solve there itself. That'll be faster. You put some 2, 3 values of x, appropriate values, and then solve. Okay, that's a shortcut way. But did you understand the logic here?
Yes, sir.
Okay. I'll give you a practice question actually. Do it as homework. 2x square plus 5x plus 4 divided by root of x square plus x plus 1 dx. This is practice. Practice on this. Okay, figure it out. Now comes the next type. A pretty interesting one. Dx by a cos square x plus b sin square x dx by a plus b sin square x or dx by a plus b cos square x or dx by a sin x plus b cos x the whole square dx by a plus b sin square x plus c cos square x. The technique here is to divide numerator and denominator by cos square x. What will happen here?
Secant square x.
Exactly. On the numerator, you get sec square x dx. Okay. And in the denominator, you'll write everything in the form of tan x. And then you put tan x equal to t. Why? Because sec square x dx will become dt in the numerator. Okay. So let's, okay. Right. Did you write the notes down properly? Divide numerator and denominator by cos square x. Write all in terms of tan x. And apply tan x equal to t. And sec square x dx equal to dt. Okay. So we'll quickly solve one problem. 1/4 sin square x plus 9 cos square x dx. What do you do here? You divide numerator and denominator by cos square x. What does that make the numerator? Sec square x dx. And denominator becomes 4 tan square x plus 9. Okay. Suppose there was a constant term here. I included that case also, right? Okay. Suppose there was a constant term here. What will that become? That'll become in terms of sec square x, and write that in terms of tan square x. Sec square x is 1 plus tan square x. Put that there and then bring it. Okay, understood? If there's a constant term, when you divide by cos square x, it becomes sec square x, and write that in terms of tan square x. Now what do? We put tan x equal to t, and then I get this as dt by 4t square plus 9. From here, you can take care of this. Okay. Okay, now next step. Dx by 2 plus sin x plus cos x. Okay. Okay. So type 4, we'll just write the type and then practice question. Right? Dx by a sin x plus b cos x, or dx by a plus b sin x dx by a plus b cos x. Understood the difference? Here there was cos square, sin square and all. That is when we divide by cos square x. Here is just cos x, sin x and all. Okay. And then dx by a sin x plus b cos x plus c. So here the step is put sin x equal to 2 tan square x by 2 by 1 plus tan square x by 2, and cos x equal to 1 minus tan square x by 2 divided by 1 plus tan square x by 2. Okay. Apply these transformations. Okay. What will happen here when you do that? The denominator of each sin x and cos x term will be 1 plus tan square x by 2. What is 1 plus tan square? It is nothing but sec square x by 2. And this denominator gets bumped up to the numerator. Understood? Okay. So you write the denominator in terms of tan x by 2, which you will take it as t. Okay. I hope all of you got this. Let's practice one problem now, quickly. Did you understand the step here? Try to visualize, guys. So you have some numerator here, dx. Denominator is a plus b sin x, a plus b cos x, and all of that. A sin x plus b cos x. So if you see sin x, cos x, and a constant there, you replace it with tan x by 2. Understand? So sin x will become 2 tan square x by 2 divided by 1 plus tan square x by 2. Cos x will be 1 minus tan square x by 2 by 1 plus tan square x by 2. You replace tan x by 2 with t. Because the numerator, which is the denominator of the denominator, is 1 plus tan square x by 2, which is sec square x by 2. This goes to the numerator. Okay.
Sir,
Great. Yeah, tell me.
sir, in sin x equal to 2 tan square x by 2. Is it only 2 tan x by 2? No, sir.
Yeah, it's 2 tan x by 2. Sorry. It's not 2 tan square x by 2. It's just 2 tan x by 2. I was thinking about this and I wrote it here. Yeah, it's 2 tan x by 2. What you said is absolutely right. Thank you. Okay. So here, how do we proceed? Like, okay, we'll take one question. 2 plus sin x plus cos x. What do you do here? Two tan x by 2 divided by 1 plus tan square x by 2 plus 1 minus tan square x by 2 divided by 1 plus tan square x by 2. 2 into 1 plus tan square x by 2 divided by 1 plus tan square x by 2. So here you get the numerator as 1 plus tan square x by 2 x divided by 2 plus 2 tan square x by 2 plus 2 tan x by 2 plus 1 minus tan square x by 2. Tan square x by 2, 2 tan square x by 2 cancels. I am left with this. So this becomes 6 square x by 2 dx divided by tan square x by 2 plus 2 tan x by 2 plus 3. Now if I take tan x by 2 as t, what is dt? 1 by 2 sec square x by 2, right? Okay, into dx. So you need a 1 by 2 there. So to make up for the 1 by 2, I'll multiply outside by 2. Okay. I'll multiply outside by 2. Numerator becomes dt. And denominator becomes e square plus 2t plus 3. From here, you can handle the rest. Right?
Yes, sir.
Did you understand the technique here? When you see something like this, you have to apply this technique. Okay,
Yes.
I hope you understood the logic of the technique. That's all that matters finally. All right, so yeah, we'll continue the remaining in the next class. It'll take some time to teach. All right, integration by parts is there. Yeah, there is quite a bit. Okay, there is quite a bit only for indefinite integration. Yes. Okay, guys, we'll continue this in the next class. All right. Partial fractions and all, I can't teach in 5 minutes.
Thank you,
So
sir.
we did the
Thank you,
easy
sir.
parts right now. We did the easy parts right now. So next class, we'll be doing little more complicated parts. Okay. Derived substitution. Okay, so we'll try to enter definite integration by next class. All right. Okay, that'll be our attempt, but let's see how it goes. Okay.
Okay, sir. Thank you.
You have any conceptual doubts regarding this class? Anything you didn't understand like fully? If you want more practice problems, I can give you homework also.
No doubts, sir. Sir,
Okay. Yes.
can you give practice problems like at the end of this chapter?
Like from the portions with the end of the chapter or right now? I'll give you some practice problems.
Yes, sir. I'll do.
Okay, yeah, I'll just give a couple of practice problems. You guys, the class is done. So just watch the video and note it down later. Those who want to note it down now, can note it down. Okay, find this. Then okay, 6 practice problems for now. Okay. And I've given a few more during the class. So this should do for now. And next class onwards, I'll put more questions.
Yes, sir. Thank you, sir.
Okay, thank
Thank
you
you,
guys.
sir.
Take care.
Thank you, sir.
Thank you.
Thank you.
Take care. Take care.